assignment. No, I kind of got all the information into SPSS and did the chart and did um, the box plots, but
Mm-hmm.
it looks like all our data we don't meet the requirements um, we don't meet the requirements for the ANOVA.
Oh, really?
Largest variance is not equal to the four times the smallest variance.
Oh,
So
okay.
I think that's okay, but
Mm-hmm.
because that's all part of the assignment, but
Okay.
just so you get a heads up of what's going on. I think
Okay.
it's the yellow color. The yellow color is not four times as small as the largest. The largest is like 16, and then like the smallest is like 3.
Mm-hmm. Okay. Hmm. Okay. Interesting.
Yeah. Anyway, let's
Okay.
keep going on the preparation assignment. I'll talk
Sure.
about that after.
Sounds good.
Okay.
Alrighty. So, uh, part one. What is a simple linear regression?
hmm
I said it's a method used to fit a line to data. It allows us to write an equation that shows the relationship between independent and dependent variables. I think that's
Yes.
probably the key is the relationship between independent and dependent variables.
Exactly. Yeah.
Yeah.
Shut the door. Yep. And so I said two. What is the formula for the wiki in terms of y bar bo b1 and x? I said it's y bar is equal to bo plus b1x.
Yeah. So this is basically, it was interesting, y equals mx plus b, right?
Yep.
The
That's
slope of a line. So I'm like, why do they have to make it so much harder? Oh, yeah.
yeah. I think it's because
We're
they
using
want it to be
statistics.
different. They want to be different.
Yeah. Maybe it's because we're using statistics, so
Yeah.
it's not all, some of it's estimated, I guess. Okay, so number three, the slope in that equation is the negative 2.2. And the y in that equation, the y-intercept is the 1.34.
Yes. hmm
Let's see. And if you plug 5 in for x, I got negative 9.66.
Me too. That's
Okay,
exactly what I got.
perfect.
Great.
Alrighty.
Alrighty, part two.
Two.
What is the explanatory variable? That's basically your x variable, and that's going to be your head length because it predicts
And
the body length and it's independent of the other.
okay. Now the x variable is always the independent, right?
Yes, or the
Okay.
explanatory variable as far as the statistics is concerned.
Okay.
They had a lot of explanation about that in the wiki. I remember.
Mm-hmm.
I can't remember the exactly what it said, but I remember reading about it saying like, "Oh, this is what we need to do to understand what should be the x variable."
Right.
I'm just logging in here now to the
Okay.
BYU Idaho online
All right.
here somewhere. Um, uh, the next length was the response variable, and that's the body length.
Mm-hmm.
That one's cool
Yes.
because
Yes.
it depends on your head length.
Correct.
That's going to determine the body length.
Correct.
My paper's falling off right now.
All right. And I never print out my plots, but I did sketch it.
You sketch them. Yeah.
Yeah, I just sketched it on my paper. Okay, number four, using the software to compute the y-intercept. So I think it's good to say that the y-intercept is the top row under the B column. So the
Yep.
negative 69.369.
Yes. Yep.
And then the slope is right underneath that, which was 7.4.
hmm
Okay. For some reason, I think I did the same thing as I did last week, where there's several different crocodile data files, and I think I opened the wrong one and then did it, and I was like, I can't find because she has the answers, right? And I'm like, I can't find that answer. Where am I looking? But then I opened the right one. So I think I keep opening because she has um, the crocodiles that start with an E, and
Hmm.
then the crocodiles that start with a G, and I think I opened the wrong one initially.
Okay.
So that was my problem because I couldn't figure out what I had done wrong, what I had missed in the reading, but then I think I figured it out.
Yeah.
So. All right, so
I found it. It says the independent variable is also called the explanatory variable.
okay,
It's just another name.
I
Okay.
vaguely remember reading that too.
Okay.
I'm gonna have to reread this whole thing like when I feel better because I have a feeling I'm not gonna retain a lot of it. So
Yeah. Go ahead and do that, Lily.
I
It,
will. Let's see. 6. So plugging that all into a formula, you get y hat is equal to negative 69.369 plus 7.4 times x.
hmm.
All right. And then I also,
Let's draw the linear regression, and you do that.
yeah. So I just sketched that in as well. All right.
All right, here's where it got interesting. For the
Yes.
observed head length of 51, what was the observed body length? And that was 343.
Yes.
And you use the regression line you obtained in number 2 above to predict the body length based on the head length of 51. I got 308.031.
Yeah.
They
That's
said,
also, sorry. Go ahead.
no, that's, I was going to say, like, that's, so the next question was asking, why are they different?
Mm-hmm.
And that's because one is a predicted value where the other is an actual measured value.
Yes. Yeah. And she meant in number 6, right? When she said use the one in number 2.
Number 6, the one she was at number 2? Yeah.
Yeah. That's what she meant, right? Okay. That's what I thought. Okay. So that wasn't too bad.
No, that wasn't that
That wasn't
bad.
too bad.
Could have
You
been
know,
worse.
yeah, statistics is not going as hard as I was anticipating it being. So, luckily,
Yeah, I
yeah,
would
we're
agree.
almost done. We're almost done, and I don't think I was ever like completely lost. So that was good.
I agree. I agree.
Yes.
Not too bad as far as I was concerned.
Yeah. Thank goodness.
It's good news.
Yeah. Agreed. All right. I'm just gonna open up my quiz here.
All right. Let me know when you're ready. We'll start it. I
Okay.
got my pen. Got my thing here.
Uh, let me see. Let me open up my SPSS really quick, because just in case we need it.
Sure.
It times out if I don't use it, so goes on me.
Well, yes. No, I don't keep tabs on it. That's that. Calculator, just in case. Right here. And okay, got it.
Almost there. Slow. I'm sorry, Josh. We're almost there.
No worries, no worries.
I'm slow.
Oh my gosh, I had tacos yesterday.
Uh-huh.
Taco Bell, so we went out together.
Okay.
Never eating Taco Bell again.
Yeah. I haven't been able to eat Taco Bell since I was in college the first time.
Oh
Yeah.
my gosh.
Yeah, no. I
Worst
feel,
food
you what?
ever. That's the worst food ever.
Yeah, agreed. I like McDonald's. I can't even do McDonald's
Oh, I
more than
can't do
once or twice
McDonald's.
a year
I can't do
anymore.
McDonald's anymore. I can't.
Yeah. Once in a while, I'm like, oh, one of their hamburgers sounds good. And then I eat it and then I feel awful.
Wendy's is fine, but
Yes.
not
Yes.
McDonald's. Oh,
Agreed. Yeah, no. My kids, every once in a while, those golden arches are just so tempting for your kids,
I
but they're
know.
not. They're not good. It's not good. So, ah. The funny thing is out here. Have you ever lived out west?
Yes, I have for seven
Yeah.
years.
And they're everywhere, right?
Yeah.
We've got
Yeah.
McDonald's everywhere. Here, we don't even pass one for like four towns. I mean, it's like
Where do you
we
live?
we live in Simsbury, Connecticut. Um, so there
I
isn't a
thought they.
McDonald's.
I
You
thought
what?
they would. I thought they'd have lots of McDonald's. I know we do. About 10 minutes that way and 10 minutes the other
Uh,
way, but
there's one in a town. Let's see. Like if we go a certain way, we'll pass one. It's in the town. I think actually it is next door to us, but there's not one in our town, so we hardly ever pass them, which is nice because when we lived in the West, we passed like four going anywhere, and our kids were like McDonald's, McDonald's.
you know what the other one was though? Sonic. Sonic was
Yes.
great. So
There's
is
only
there's
one Sonic out here.
yeah, it's only
Well,
in Boston as far as I know.
yeah, Sonic is
Sonic's
good.
anywhere else.
Yeah, right where we are, there's four Dunkin' Donuts in our town.
Yes, yes, Dunkin' Donuts everywhere.
Yes,
Like
every
like
time.
right next to our house, and then there's another one too, like right where next to the McDonald's over there.
Yes, us too. So every time we pass a Dunkin' Donuts, my kids are like, "Can we have donuts?"
I
And
know.
that's
Ugh,
that's the one.
I like their hot chocolates so much.
Yeah, me
So
too.
bad for you.
It is so bad
I
for you.
gained like I gained like 10 pounds just drinking those. Oh, they're so bad for you.
hmm They are bad for you. Actually, you know what I really like? Starbucks, they'll steam milk and they'll put like I like to put caramel and almond syrup in it. It's so good. And
Really?
then it's milk. It tastes like it's almost like hot chocolate, but it's not as rich and it's actually good for you. Not terrible for you.
No way, really?
Yeah, just steamed milk with some of the flavor syrups in it are really, really good.
I'll have to try it out. I don't
It's
go to Starbucks too much because it's like coffee, but
yeah, yeah.
the last girl I went on a date with we went to Starbucks, so it's a bad
Okay.
time. So it's
Yeah, the most of the people that I'm friends with out here are not Mormon, so they are like, let's go have coffee. So I had to find something
yeah,
that
nice.
I like. Yeah, and I like the steamed milk. It's yummy. So, all right, I'm ready if you are.
I am ready. Let's go for it.
Okay.
Start this shindig. All right.
Number 3. The y-intercept is the 2.0, right?
Yep.
The slope is the other one. Positive. Did you just get 7 for number 5?
7.
Yeah.
I got 1.
Hold on. If x is 16 times 0.25 plus 3.
-3.
No, they're both positive, aren't they?
Look closely.
It is -3. Oh, you can barely see that.
Yeah,
Okay, so you just got 1.
that's what I got.
Okay. I didn't even see that negative. Jeez. Hold on, let me make this bigger. There we go. Now I won't miss it.
Tricky,
Okay.
tricky.
That is tricky.
All
Okay.
right.
Okay. Um,
Make a scatter plot of the math self-efficacy data. Let's see here. Let's go to SPSS here.
oh my gosh, I have to go let my dog out. Hold on, she's
Don't worry. Yeah, I hear that.
driving me
I can hear her
insane.
crying. Go ahead.
I'll be right back.
Burp, burp. Scatter dot.
All right, sorry about that.
That's all right.
Luckily, she's fast. She doesn't like the snow. So, all right, we're doing a scatter plot, right? Is that what they said?
Yes.
All right. What are we doing it for? The gender, the score, or the confidence rating?
Hmm?
Did you do it on gender and score?
I did it on score and mean rating or confidence rating mean
Okay. How do you know it's not gender?
because there's only one because there's only 2 genders.
Oh, okay. Gotcha. That's true. Sorry.
No, it's okay.
All right. That kind of looks like a hot dog.
Looks like a hot dog to me.
Okay. All right. So would you say it's appropriate, right?
Yeah, I'd said it's
C.
appropriate. I said it was C,
Okay.
which is kind of a yeah.
Yeah. All right.
You know what you get for 8?
Okay.
It's a weird question. How many observations?
So it looks to me that there's 139.
Yes, that's what I said.
Is that what you said? Okay.
Yeah. All right. I don't know what the
That is a weird
I don't know what
question.
that weird question is asking me. 139.
Yeah, that's weird.
Okay.
Okay, so now we've got to go in and do the analyze.
Let's do this. Find this here. I gotta do this again.
Okay. Confidence rating.
Scatter dot. Simple scatter dot.
So are you saying the score is the dependent?
Confidence data is the confidence rating is the explanatory value, which is X. Score is Y as the response variable. So hit OK. That looks like a hot dog to me. Oh, and you got to do a linear regression. Okay, I know how to do this. You double click this bar chart.
Hmm?
Elements fit line at total. Okay,
Okay.
I got 18.69.
That is also what I got. 18.
Slope 12.69. What is the predicted value of y when x equals 4?
Hold on. Where did I? Sorry, I can't find my quiz. Hold on. There we go. 18.69. Got the slope at 12.695. Okay.
Dependent is your confidence. No, your
4. Did you get the slope at 12.695?
I'm working on that.
Oh, okay.
Sorry.
That's okay.
I got 69.469.
Okay. I got 69.47. Let's see. How did you get so many numbers here?
Me?
Yeah.
I did the whole go into analyze, go into
My statistics
regression,
viewer?
go into analyze, go into regression, and then go into linear, and
Yeah.
then you put your dependent in the variable and your confidence in the independent, and then you
Yep.
go to save button, and you click unstandardized, and then you hit continue, and then you hit OK, and then it shows like another column. It's called pre-1. And that's what the predicted value would be for the regressions. It's in the wiki. Like the wiki talks about
Mhm.
this.
Yeah. Okay. Oh, see, I did it by hand. That's what I did.
Yeah, if you could do it by hand, you'd probably get the same thing.
It was very close. Okay, so hold on. What's my value here when x is equal to 4? Did you put the value in?
I did.
You did? Okay.
You have to put it at the bottom,
The
very bottom,
bottom underscore, right?
under confidence mean rating.
Oh, okay.
Confidence rating mean because it's direct.
All right, now I have to do it again. Hold on. The funny thing is if you do it again, you get the pre-2.
Yeah, you do, but it's the
So,
same answer.
so you got 69.46935.
hmm I just said 469.
Okay. Okay. Confidence rating is all. Okay, sorry, what?
What is the maximum predicted value of y for these values of x? Okay, so if confidence is your x,
Uh-huh.
scale is 1 to 6, the maximum predicted value of y for the value of x
Mm-hmm.
should be, that means I gotta do this again, this linear regression thing.
I'm not getting this at all.
You're not getting it?
No, what is she asking? What are we plugging that into the equation? To the y hat equation?
Hold on. Let me just
Okay.
write to figure this out. No.
Okay.
Okay, got it. So, what was your question? You don't understand?
So yeah, so what are you doing to figure this out? Are you just plugging it into the y hat equation somehow?
Okay, so they want to know what the maximum y value can be for a predicted value of x.
Right.
So, you know that x can be the numbers between 1 through
One
6.
and
It can't be
six. Yeah.
higher. So,
Right.
they're asking you if x was 6, what would your maximum predicted y value be
Okay.
for the values of x? That's what they're asking for number 12.
Okay, but how did you figure that out?
I put it in. Wait, hold on. This is hint. Because there's a positive correlation, we can use x. We can use the largest x value to find the largest predicted value. Wait, really? Oh, 97? Now I'm really confused. Wait. 6.0 is 93. Hold on. The hint. Because there is a positive correlation,
Mm-hmm.
we can use the largest x value to find the largest target predicted value.
Mm-hmm.
Because
I'm
there's
just wondering, is
correlation.
there an equation that I don't know about? Did I miss it?
No, you're doing the same thing as you did for 11. You're just gonna do it for 12. Except instead of 4, you're finding 6.
Oh, so we're using the same data file.
Yes.
Okay, that is what I was not clear on because it looked like it was a completely different question.
No. I'm just trying to figure out what it means by there's a positive correlation. We can use the largest x value to find the largest predicted value of y.
Which should mean we should only have to find six, right? We don't have to do all the values 1 to 6.
Right. Right.
Okay.
Understand why is it tell me you can use the largest x value to find the largest y value?
So 6 is the largest x value, correct?
Yes.
So if we have 6,
Okay. Okay.
it'll give us y hat.
Yeah.
Okay, why is this not working? And my computer's frozen.
No. First.
That is the worst. Oh no, I can't even get out of this.
Oh crap! Just give it a minute. It'll fix
Yeah,
it.
I hope so. I'm gonna have to give it I can't even like minimize to get back to my quiz. Oh, okay. It disconnected from my VMware. Hold on.
What? Oh, from your.
From my yeah. See, I should have just bought the stupid software, but I was being stubborn And now we're almost over, so I don't want to buy
That's fine. You shouldn't
it.
now in this. It says how many explanatory independent variables are present in a simple linear regression. Is it just one? Or is it
Yeah, I think it's just one.
just one?
In a simple linear regression, there's only one independent and one dependent.
Right?
Right. I
Okay.
would think so.
I would think so too.
Oh,
It's
crap.
just kind of like a weird question.
It is. So what did you end up doing for 12?
I ended up putting in six into the math efficacy data set, and then I used
Okay.
the same method. I used a simple linear regression to understand what the value was, and I got
Mhm.
94.859 for my answer.
All right. So you basically just plugged in
X
whatever you did for
as
6.
6.
So you plugged in y hat and then used, okay.
I
I
plugged
think I get
X
it.
in for 6, and then I found out what Y hat was by
Okay.
using the predicted value
Okay.
regression, and it gave me 94.859.
Okay.
You kind of
It's
see
not
how
letting me it's not letting me get back into this stupid VMware here. It's so annoying.
that is horrendous.
Horrendous. All right. Um, I'm gonna write that down and figure it out. Hold on. Ugh, annoying. Here we go. I apologize. I just want to make sure I understand what we did that. How you did that.
It's fine. It was 94.859 was my answer.
94.859. Okay. Oh yeah, it even brought it all back up for me. Here we go.
Oh, nice. That's good.
Yeah. Perfect. There we go. Okay. So analyze regression. Okay. 94.89859 is what you got for Y hat, right? The pre dash 3. And that's what they were looking for? Okay. Okay. 0.859. Yes. I got the same thing.
Oh, you did? Good.
Yes.
Okay.
Okay. Okay. Let me just make sure I didn't screw anything up here.
As long as you get it.
Yeah, I got it. Okay, I'm submitting.
Go ahead. Let's see what we both get.
All right. Woohoo. Perfect. Okay. I
What?
think, what? I got 100. What did you get?
I got a 93. What is the slope for my math efficacy?
I got 12.695.
I just wrote 12.69.
Oh, that
Honestly.
stinks. Honestly. Seriously. Okay. I think that why I wasn't understanding that is I was for number 12. I think I was anticipating that it was not using the same data. And I was like, well, where am I going to get the data?
Right.
Okay. Because it said confidence data, which wasn't self efficacy data. So I was thinking something different. Okay. Alrighty.
Right.
So project.
Projects. Where was I here? Okay. Let me open it up here again.
Mm-hmm. This is
File.
describe the data. Yes.
Okay, so I got the charts, I got the simple linear regressions, and I got all not the simple linear regressions, the data in the box.
Mm-hmm.
What in the freak? Who is messaging me? It keeps messaging me. Okay. Let me just open this stuff up. Okay. So I have all bags. I have all 10 bags.
Okay.
My bag, 2 bags. I have Natalie's 2 bags. I have your
Okay.
3 bags, and I have
My sister's 3 bags.
there's 3 bags. Yeah.
Okay.
So I have a total of 10. Even with 10, though, my yellow comes up short. It's kind of stupid.
That is kind of stupid. So there was somebody that had a bag with only 3 yellow. Was that me?
Really?
No, no, I'm just wondering if it was.
Yellow
No,
9,
it was not mine.
yellow
It,
9. Yellow was 9.
yep.
Yellow was 9. Yellow was 9 here. Yellow was 9 there. Yellow was 12 there.
Yeah.
Yellow was 13, 10 there. Yellow was 10.
Yeah. So it wasn't any of mine. That is interesting to only have 3 yellow. That's so weird.
Who had? Yeah, I don't think any of the data you gave me was 3.
No, no, I'm just looking at my data. I have it printed out, and it didn't. None of mine was either.
Yeah,
Okay. You didn't like forget like a one in front of the three or something. It was truly somebody got just three.
no, I don't have that
Weird.
data set.
Okay. Um. So.
As far as describe the data goes,
Mhm.
we're just supposed to put in the data and make 2 paragraphs about the
Okay.
the information, right?
Right. Yeah. It says
Paragraphs.
1 to 3 paragraphs, which tells me Skittles. Probably 1 paragraph is probably good. Skittles.
I know, right?
I mean, how are we going to write 3 paragraphs on Skittles? I don't even know how to do that. Let's see.
Graphs will also be evaluated on helpful and accuracy labeling. Title, final
Yeah.
project, design the data. The names of all the members are on the top. Your
Mhm.
research question.
Mhm.
That
Oh,
is,
my research question, I think we need to make sure. I think initially I had put in like a 6 ounce package, but I think the small ones are only like two. So just make sure that you don't put 6 ounces because 6 ounces are the bigger one.
yeah.
Yeah.
So let's change that. 1 to 3 paragraphs summarizing and describing our data. I was gonna say one of us could do like you could do the paragraphs.
Uh-huh.
I'll write out all the data, but
Okay.
I don't know if you need the data in order to write the paragraphs, which probably makes sense, right?
Let's see. Paragraphs. Clear, concise. Sure, the paragraphs include a topic sentence, 4 to 5 supporting sentences, and a concluding sentence. I'm probably only going to write 1 paragraph because you think she says 1 to 3, so I think 1 paragraph is plenty.
Yeah. As long
What
as
would
it's
it,
very concise.
yeah, what would the topic sentence be? What does she mean?
Probably the
Like
topic
we
sentence.
we set out to find if
Yeah, probably
the
explaining
distrib-
what all this is going to be, like an introductory paragraph. Sorry, an
yeah,
introductory sentence. Like
okay,
our data of finding Skittles was the following. Blah.
okay, okay, yeah, I can do that, and then I'll send it to you. When do you want it by?
Um, as soon as you can. I mean, preferably before Saturday is great.
Yeah. What if I send it to you tomorrow? Hopefully I'll feel better tomorrow.
Tomorrow's fine.
Tomorrow's good. Okay.
Tomorrow's good.
All right. So it'll probably be something like, we set out to find if, the colors in a Skittles bag are all normally distributed,
Do you want
or
do you want me to send you the data? Do you want me to send you the I can send you all that I did for
the graphs and stuff.
graphs and everything, which
Cool.
I should have it by either right now or later. As soon as I'm gonna try and finish out the homework right now because I don't think the homework's that difficult.
Yeah.
but I understand. I can I can get you with the data just in case you need that to write something.
Okay. Yeah, it might be easier to write
Because
than if
all it is the box plots and the
mhm.
histograms and the. I wonder if you need to include all that stuff. I'm
I
gonna do
think
it.
so.
I
Yeah,
would
I
think.
think she wants all of the graphs and whatever we do. I think she just wants less than 2 pages, it looks like. No more than 2 pages. So, um, okay. Alrighty. Looks good. So I'll write a paragraph, I'll send it to you, and then if you want to make any changes, you can make changes to it and submit it.
Sure.
Does that sound good?
Yeah.
Okay.
Do that.
Perfect. So yeah, just send me the graphs and stuff. That way, if I need to, I can use them to help write the paragraph.
Oh yeah, most certainly.
Okay. Perfect.
Okie dokie.
Alrighty. Okay. I think that's good. And then this upcoming Monday,
Hmm.
I am working. I was going to take P time so that I don't have to miss group. Is there any way we could meet a little earlier on Monday?
We could. What time are you thinking?
Whenever you think. I mean, technically, I'm supposed to be to work by 7, but I mean, if we could meet at 7, then I only have to take, an hour or so of P time.
Yeah. Trying to think. What? 7 o'clock. Yeah, we can
Yeah,
meet at 7.
at 7. Okay,
Yeah,
cool.
definitely.
Alrighty, sounds good. 7 o'clock on Monday.
All right, 7 will be there.
Okay, cool. Thanks, Josh.
Hey, thank you, Tabitha, very much.
You're welcome. Talk to you later.
Yep, we'll talk to you
Okay.
later. You take care.
Thanks. You too. Bye bye.
Bye bye.